Okay, so in other videos I actually showed how I booted Ubuntu that I boot from mainline, and there was also another part of that was actually creating the right phases for mainline Ubuntu to be recognized. So this is essentially the terminology of creating FIP, that is Firmware Image Package, and there are some things that in particular for these AMLogic devices are some signatures we saw like this at AML, and some configurations like the memory timing, like the memory clocks and DDR initialization parameters, that for each device can be a little bit different, and they're also part of the image. Now, these things can be very, very, very challenging to achieve. One can understand what figure out, and some people understood it by reverse engineering the binaries, like in the first 1 megs or 2 megs of the eMMC, or like the sdcard, like a bootloader. But essentially, things start from somewhere, and in this case, this somewhere is this Android tree. So I will just point out a couple of things. I'm not going to analyze it completely. This would be something that one could flash like to an SD card, okay, and it's like paired somehow. And these two nice fellows enable to load some DDR timings and to load Ubuntu via USB. This is why they have like the USB. Both of them are done via USB. They can be done via the flash tool, and they can be done via protocol that AMLogic uses that the flash tool implements. And also the other project that I mentioned before, AML boot, that does just this. Now, if you use like the letter or the former, but the letter for sure, you will see all kind of addresses, and you might think, hey, where did they take it from? So the idea is, and these fellows come like as pre-built. This is like it's not an Android internal class, but it's part of the thing that are being done as part like of the build. And they're really pre-built here, okay? They define it. So look what we have. We have several things. We have platform.conf, and we see DDR load, DDR run, Ubuntu load, all kind of like addresses that are being used, and commands that this is what would pass like via the USB protocol, and that's what I want to show essentially. So for like the burning tool, there would be like a way to package an image, and we saw AML upgrade package image when I recovered the previous one, and this is also via having this one. This is how it was created. Okay, so these are outputs. Okay, and if we go to, let's say, this is how the device itself would look. Let's go to out target product pin 281 upgrade. Forget about like the broken links, it's fine. We will also have we'll also have the package conf here. That's taken from another place, and look what we have here. Like for the image itself, we do have those that are being transferred like by USB, and the other ones will be they will be set by like the corresponding like tools. Let's say if Ubuntu already is being loaded, then it will tell him command, hey, please put this, please put there, and Ubuntu will be loaded by these two fellows. And the rest are Android partitions. They're for the tools. It's not like a lesson about the tools. My objective is to be general, but I'm explaining about this particular device. Okay, so why am I even telling this? Because as we mentioned before, at least I first recorded the video about OTAing the package that I already created. And I mentioned that there are timing issues, and they are intentional because they're part of a course, and those who took courses with me I almost always give deliberately broken or vulnerable software firmware devices, because the objective of my training is to train, and you train with real problems, and real problems, they take a lot of effort to come up with. So sometimes if they're like very deterministic, that's fine, but if there are things like, okay, coping with like messed up memory, it's not so easy to create something like that. So I provided those DDR timing and files that came from like another project, okay, that were good enough, but they were overclocked. They ran at like 912 megahertz, where this manufacturer would run the DDR with 660 megahertz. So the idea is that when U-boot is built, and I moved it now to another device, okay, it looks something like this, and it has some pre-builds of FIP. Those encrypt files, they are meant to allow the untrusted firmware that is being loaded, and the untrusted firmware itself, to be loaded. It can be used for secure boot, and even if secure boot is disabled, there is the loading chain, and the AMLogic signatures are definitely taken into consideration, and without them your device will not boot. So building U-boot itself is not enough, you also need to package them. And for there are tools that, unfortunately, this is something old, are being, like, the manufacturer itself had it built like for Python 2.7. So there is a solution for that. The solution would be to have a Docker with like a Ubuntu 16.04, or 14.04. Holy cow, 16.04 is almost 10 years ago. How did this happen? All right. So yeah. So I mean, you need to start and install software and do things and do that. And who needs that? So first of all, some good people upgraded this type of script to Python 3, which is nice. But the projects that are being given, they usually don't have the entire chain. And what is like this entire chain? So this would be like an output. It's perfectly fine. The different files here say where they go to. We already encountered the BL2 and the TP and the TPL, ternary program loader. And encrypt means that it puts like the right metadata and perhaps also like signatures and so on. And the FIP create tool will create like the firmware app that package, and it will use, when we build, we will use this tool with like the right family of system on chip. So this one is the GXL, and then things get more complicated for two reasons. One, okay, for three reasons. There are a lot of files. Okay. Two, some of them are being created as part of the build, some are not. And three, but when you get something from a vendor, it's very likely to get it. And three, there are some new and not new file, and go figure out what is the right one. So there is a way of figuring what the right ones are, but the important thing are the numbers. So the idea is that you have here, let's wait for like a little bit. We have BL 3.3, that this is where U-boot itself will load, okay? Now there can be BL 3.2, and this is in the ARM trusted firmware specification, where in 3.2 you will have some code that can run like in secure monitor mode. You have a 3.1 that is like the first initialization of the secure monitor, and you have 3.0 is if you have like like a system control processor. It would be like Cortex-M, like Cortex-M3 or something like that. You may have it, you may not. It's like the firmware management processor. Okay, it's like a microprocessor. Why is this useful? Think of like, okay, let's say you have something and you have some peripherals. How exactly would one know that that you like press like the remote controller or an Ethernet package can? Okay, so like in Ethernet package, well, if the Ethernet has like a controller, it's great, but it needs to notify like someone. So and the someone needs to notify like this big quad-core processor that knows to to translate the image itself. This is like called the application processor. So there can be a design where you don't need like all of this. I mean, you can't necessarily like interrupt it. It depends like how you make like your system. But you can make like a microcontroller that doesn't consume much power. You keep it an always on. You will hear something like an always on domain, and then you would be able essentially to keep some low power stuff. But this also has firmware, and this also has initialization code, and it also needs to be handled. So a lot of time, like this, it's called the SCP, it will build BL3 0 here. Now BL2 and ACS have to do with initializing the DDR, and we need all of them, and the FIP create script packages them nicely. Okay, so essentially the only thing we really care about for having U-boot is BL3, but someone needs to make it, and someone needs to call it, and someone needs to say, hey, everything is okay. So we need this chain. Okay, so I actually came and did some work on that. And I put it in the following URL. Okay, on github.com/Aaron PSCG AMLogic boot FIP P281. Okay, and essentially the first version of it had something that came directly like from the Libertech Pro. Let's see where exactly I took it from. Yeah, from LibreElec AMLogic boot FIP. Okay, I took the LE Potato device, which is pretty similar, and it worked. If we take the P212 device, then it will complain, hey, this is not like the chipset like for this S905W. I can perhaps show it as well. So this project, and it has like these instructions on exactly how to do it. We say where to take like the U-boot binary that we built from the mainline with the right config, and where we want to output it to. Okay, so the original project had all kind of libraries, just like we have like this GXL here. And what I did is I just narrowed out things and put the things that are important. Okay, and the build FIP script here and the build FIP script here, it essentially it's just going to go, and it needs to send to the device. Where is the name of the tool? Yeah, so it has like the make file. And the make file called this include, amazing. And these are the definitions that build whatever needs to be built with, let's see the script that this is the clean, with BLX fix, with calling this already compiled Python tool, okay, and then for each level calling like this BLX fix, and at the end of the day taking U-boot and creating the right set of tools here. Okay, so you can go look at it, it's not too long, and this is what's being used. So if I go, so here is what I already have copied, like on the P8 one. So I copied these things from, let's see. Let's just do star. These are the ones that I have. And MD5 sum star here also. So let's have a quick look. 745. And we see that it's the same ACS, okay? Let's look randomly on something else. So BL301, okay? So FC and FC, so you can see I just copied it. I could have taken the new ones as well. They are like after like a specific build here. So I will show the different perhaps. But the important thing is this is how I created like the image. Now if I want to go ahead and let's see. So I put a device here and let's do this. The build FIP tool needs to have like another directory, so let's send new blah. Let's do foobar. Foobar I will remember. And I would want to do build FIP with some U-boot that I took from somewhere. So I think this was something that I built. That doesn't look like it. I think that's fine. Let's see how big it is. Looks like it, alright? So just for fun, I'll copy it. So it will be shorter for us. I'll copy it to my U-boot. Just for fun, okay? It doesn't really matter. And I'll do like build FIP, okay? But before that, I'll do something else. I'll do a quick backup. This is what happened like in, I will likely, because some people asked, like too many of them that have not been in the course, said, okay, whatever, I don't like to spoil for the people in the course, but those who are determined, and they'll pay attention when I tell them, don't look for answers. No, most of them look for answer anyway. They want to get as much information as possible, but information is insignificant. The important thing is doing. This is how you learn. And finding out the solutions. This is how you feel much more accomplished as well. So, yeah. Yes, I know how to git stash, but just for fun, I'll do new ones, P81, okay? And now what I will do is, yeah, so I'll check out, I'll add readme, so it's not so weak, I think it got everything, but maybe I'll update it, maybe with the video contents. So, where were we? Yeah, so I'll just check out everything here, okay? Good. And I will run the instructions, at least like this is one of the things that PSCG builders does. Like it calls this folder like with my parameters, and then it does it calls copy to media to, this is file that I made to create like a an image file that we'll later put as part of like the image that we create and flash to the flashing device, like to the SD card. So if we do like build FIP, we'll call it P81. We can call it also like the new whatever it looks like in the folder. And how did I call it? My U-boot bin. That's how I called it. And the output directory would be foobar, right? So if I look at foobar, then I have these fellows. So I can go, and remember these addresses that I showed at the beginning? I can go modify this U-boot bin, use the flashing tool or PyAML boot or whatever that can write via the USB, and then my U-boot will be flashed. But I don't know if I uploaded it or not. Like for the AMC glitching, this particular U-boot might have problem and get stuck like the AMC. So we do all kind of things when we recover. Okay. So I have an SD card inside. Basically, if I have a partition table, it will reside at a offset 444, I think, 445. And I would want to skip it, like between 444 and like the first sector and 512. Now I don't care. I'm just going to flash it. I have like a new SD card. I'm going to flash it as it is. And there was something there before, but never mind. And let's do like a ddif equals U-boot. Whoops. U-boot. Sorry. Sudo ddif equals foobar, right? U-boot bin sd bin, and of equals dev mmc block 0. That block size doesn't even matter, it's going to be super quick. Alright, I'll do sync, and now I'm going to take the SD card and put it on the device. Now, this is a device that we wiped in the previous video. So let's see if it has any effect. Well, apparently it does. So stop to start U-boot. So we have like bootloader. This one also has like AMC. Okay. So it's not so bad. Something did happen here. Okay. And I didn't wipe the entire MC. I just wiped the first 2 megabytes or something like that. So we have a U-boot here, and it's the U-boot that I put, and everything is like great. All right, like with the SD card. If I take off the SD card, boom, we have these things here. But this was the default, and the default, it's going to try to put like the frequency here, and then do hey DDR3 channel failed, yada 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 yada, and then there will be issues with it. Okay. So I put the SD card again. It's going to try and boot. So we have something that is booting, and it's already better. It's great. And now we can see it cannot find what it wants. It's going to try to boot P broadcast. That's perfect. Okay. That's excellent. I'm connected to Ethernet. I did not provide like a TFTP server though, so it will do this. So excellent. So we have like this DDR, and if we load like an operating system, perhaps we will be lucky, perhaps we will not be lucky. So now what I'm doing is something else. Now I'm going to take this nice card, and I'm going to go back to where we were, okay? And before I add like a copy, and I'm going to do something else. I'm going to just copy everything here, the new ones, to P281, and I'll run the same command like before, and I'll do the disk dump, and I'll sync, and I will put the SD card and reboot the system. So something is recognizable again. And now where is like the CPU? Still like fail, fail, fail. It's not very happy about it. Okay. It's not a huge deal. Where is the 6 something here? Let's see. I mean, it's really not that important, okay? So someone is not very happy about it. So basically this illustrates like our mix and match here. And of course that I did not copy. This is why it didn't work. So of course. Yeah. Okay, so let me do the process again. I mean, there is another gotcha here with the new and not new, but I wanted to just go and advance it a little bit. So I copied, now I already built, I will disk dump the amazing foobar. Such a wonderful name. I didn't think. Let me do it again. Let's not risk it. Didi flash this. I can do with the conv fsync, but it would be typing more and don't want to do it. By the way, like just know, like when you when it's like waiting, when the device is like waiting, let me disconnect and connect again. Now I have like an SD card here. When the device is waiting, you will not everything will be initialized as you like expect. Okay, so it's something worth knowing. Where is like this CSB and frequencies? Yeah, so look what we have here. DDR3 16-bit at 660 megahertz. Okay, so the DDR has been initialized differently, and that is fine. That is what I wanted to show here, like the component of actually modifying U-boot. So I think that I will update. I will either upload the like the modified files, or I will upload the original bootloader file, or maybe I will do both, because otherwise I will definitely forget what I put, and it will, yeah, whatever. So, but the important thing to take from this video, that was probably much longer than I intended it to be, is what happened when we actually want to replace the bootloader. We showed how we have something that works and how it just works in the previous videos, but now I showed you how it actually has been created and what are the gotchas and what are the different components, like in the untrusted firmware. And before that, that has been packed into this bootloader, and that's it. With this knowledge now, you have, and with PSCG build-OS that uses it, you have the entire chain for replacing replacing your AMLogic device's bootloader and running your own Linux or your own Android or your own whatever, and having a great time while doing that.